Thank you, not only for the introduction, but also for everyone who's here. And this is actually a really intimidating lunch group to talk to because you are all on the front lines of making this happen. And by this, I really mean what Dave Hochschild said this morning. This interplay between what we need to do, what the reality of energy markets, water opportunities, environmental justice, it is a huge challenge to keep all that going, and it's a testament to the fact that California can do it, that people like you really make it happen. So I really want to bore you in the beginning, give a few highlights, and then really depress you at the end. And so that, if I do that, I'll have succeeded in my lunchtime job. So thank you all for being here, and I hope I can at least highlight why I think what's going on in this room and with the CCA movement overall is so critical to a job that we in California are on pace for, but as you all know, that's not nearly enough. And if I don't bore you enough as we go along, the website for my laboratory where the slides from the talk and other materials will be. We just did a Wharton's a Knowledge at Wharton radio show this morning about the private sector leading the clean energy transition. So that should be posted by tomorrow morning. And the Twitter is not my vacation pictures. It's designed to be kind of one tweet a day about the work in the laboratory and about some of our colleagues at Berkeley. And so I'd welcome any of you who want to follow it, comment on it, et cetera. So again, thank you all for being here. So again, what I want to do is really start off with just a couple facts that everyone in the room knows. But the context for those facts is critical in thinking about how we're going to both make the clean energy movement accelerate at the pace that it needs to. And it's really that acceleration which is the challenge given how complex it is everywhere in the world, certainly in California, and how many times California has already taken critical steps forward. And so again, I'll try to highlight that. I'll spend just a couple of minutes not doing the detailed mathematics. That's never good at lunchtime, even for grad students. But to highlight one modeling tool that's really allowed us to think about some of the issues where CCAs play a critical role, and then do two quick examples, both of which were highlighted to some degree in the panel this morning. One is this really important interplay between electric vehicles and what CCAs can deliver in the future. And then the big challenge, and that is how do we capture and utilize all of what we've learned about behavior of institutions, of companies, of individuals, of regulators, to try to get the next level of innovation happening to get us not just in California, but in the broader community on our goal. And so I'll try to highlight those. And again, this is really more of a kind of an advertisement for what I hope a lot of you are doing. And the one thing I'm hoping is that after the meeting, you will be able to send to us some of those most critical examples to illustrate some of the real challenges that we certainly face. So I want to go all the way back to the slide that everyone should have tattooed somewhere on their body in California, and just highlights this incredible and long-term evolution in the difference of electricity consumption between the U.S. overall and California. And we all know it, but when you talk about how can we anticipate what we're going to need 5, 10, 20 years down the road, it's really worth having some of the data kind of at one's fingertips. And when you look at the run-up in the 1960s with electricity use in California and across the country about the same, that dip is, of course, the dip in the California blue is, of course, the response to the first OPEC crisis, and the founding of the California Energy Commission, which led in this partnership with all of the state agencies to a series of individually important, but none of them earth-changing innovations in energy efficiency at the commercial, industrial, and residential level. And when you add up that series, you get the famous plot, the wedge, if you will, of energy efficiency, that the Rosenfeld curve, that we kind of highlight over and over again, and it's been picked at and examined, and there are some interesting footnotes where there's challenges, but that story is entirely remarkable. And it's remarkable not just because of all the innovations, but because in the 1960s, economist after economist, not just economists, I'm not picking on them, but financial analyst after analyst said, if you want to grow the economy, you must grow energy use. And there was laws written, there were articles and books that highlighted that story. And if that's the only piece of the detail of that history going back to the late 60s that one has, it's already valuable enough. But this has led in different ways to the opening up of the markets for small-scale power, understanding some of the differential aspects of access to technology, both big firms, small firms, across socioeconomic groups, the impacts on minority communities. A whole bunch of things came out from understanding that kind of not simple, but in retrospect, simple-looking story. One of the elements of that is, of course, that while we launched our renewable energy markets with this 2010 goal to be 20% from renewables, we missed it through a small party, hit the target a couple years later, but now we are ahead of schedule to meet our 2020 goals. And while there's certainly room to be worried, most of the analytic community thinks that we are on path to meet our 2030 goals of 50% renewables and to be able to think seriously. We haven't gotten a language that everyone agrees to yet, but SB 100 with this goal of 100% renewable energy or carbon-free or clean energy. There is important devil in the details of that, but this 2045 goal of 100% renewables with the incredibly important added footnote that we are not just talking about meeting our projected demand, but dramatically increasing that demand as we think about electrifying everything, from space heating to vehicles to smarter agriculture, et cetera. That story really underpins the critical need for both delivering the benefits of that at the household and community level, hence CCAs, and having a mechanism that I'll refer to again and again in the comments, and that is a mechanism to investigate which of these innovations deliver benefits and what are the unintended consequences, both good and bad. So with that kind of mini background that everyone knows in the room about California, the global story is equally critical to keep in mind, right? So we're doing this at least in part because of the climate story. And the climate story going into the Paris agreements was dismal. We'd had 20 years of meetings that had generated lots and lots of air travel, lots of parties, but not a whole lot to show for it, until the U.S. and China in 2014 came up with a plan to essentially have a G2 of climate. 40% of energy use, 40% of emissions coming from the two countries that had not exactly been on the leading edge of innovation at the national level until that Obama-Xi handshake and 2014 accord that led to countries coming in and saying all of the red were the national commitments that were made to the Paris Accord. Now this December in Poland is going to be the critical check-in meeting, and of course the only country to have checked out is us. But everyone else is going to report on where they are in actually making good on that degree of climate protection. And one of the most interesting lessons is that exactly what CCAs represent has happened at a global level. Up until the Paris meeting, essentially it was a one-size-fits-all. It was we need to decarbonize the energy sector and then fiddle around with forestry and ag to different degrees. But what came out of the Obama-Xi partnership was that countries could emphasize their own national advantages. Energy efficiency, renewables, smart agriculture, forest conservation, protecting indigenous peoples. All of those became things for which the nerds in the room, myself included, quantified in terms of the orange. That also leaves another degree and a half or more that we need to cut. But in the excitement right after the Paris Accord, the Kigali Accords came in, signed remarkably quickly, that will shave off about another half degree, largely in refrigerants and other areas. So that gives you a roadmap to where we've committed. Not that we've done it, but gives you a roadmap to both where we've committed to go to the yellow line, and then knowing we need another degree to get to 2, but there's an exciting international movement to make 1.5 degrees the new target, which makes all of the work we're doing so much harder. The challenging part of that story is, of course, the longer we wait, the higher the peak gets, so the more we need to cut emissions. But the big worry by having the U.S. slow down to a near stall at the federal level is that if we look at these lines of decarbonization that would get us down to that all zero carbon or all carbon free or all renewable, depending where how you want to phrase it, only the first line, only the blue line, is at a slope that we've ever done before. That's about 3% per year decarbonization. All of the ones, if we wait and delay, are levels we've never done, meaning we in California and the other places like Denmark and Eastern China that have decarbonized rapidly. The problem, and this is the first bit of bad news, is that while we are doing great by many of the metrics in AB32, we've never done 3% a year here for anywhere near this length of time. In fact, right now we're doing about 2.5%, which means that we're not even for a couple years on the path to get down to the level of decarbonization we need to do. Hence, if we don't figure out what works for homes, communities, neighborhoods, rich and poor, this is a no-way path. And so figuring out what goes on in the CCAs around California, similar neighborhoods in Europe and Australia and elsewhere, those lessons have to be collected, distributed, disseminated, and adapted incredibly quickly. Now, of course, we've had a little problem at the federal level, and so I was serving in the State Department, but couldn't keep serving, and so I did write a little resignation letter. I did embed a little message in the letter. And of course, the amusing part for me was that I got asked by the first reporter's questions when I resigned was, did you intend to have this message in there? And you don't phrase some of the sentences so awkwardly if you're not trying to get that done. One of the things that I learned from my teenage kids, though, was that you don't just write the letter and put it on Twitter, is that you need a strategy to disseminate. And the state agencies, the private sector, the CCA movement is in fact that effort. So in my own case, you write the letter, but then you find your most well-known friend to disseminate it. So I found the most well-known person I know and asked her if she would send it out. And it definitely has an impact when J.K. Rowling retweets your message. By the end of the day, it has sort of gone viral, as my kids told me. But this is as important as the initial part of the story, because as we know, California is less than 2% of greenhouse gas emissions. So if these lessons can't spread quickly, we're not going to get to our global goal, even if we green individual communities, rich and poor. So it's a really critical interface, and thankfully, we have state agencies that work really hard to get the messages out. And so I would urge, even for those things that don't work, that we find a way to get those messages as quickly as possible. And again, that's where the diversity of CCA approaches is so critical to the story. So in my own work, I'll do a very short digression into the absolute nerdy weeds of the story. One of the aspects of trying to tell the lessons for what's happened in California, what's happened in partner cities, states, and regions, for us it was to build an open source model of the power grid so that we could sit down with utilities, with some of the private sector players, and compare the results. So what I won't go into in the details here is the precise analytics of this model, which we call SWITCH, which is solar and wind integrated with transmission and conventional power. For us, this was an exercise in quantifying everything. What's the cost and the value of reliability? What's the cost and value of DSM efforts? What are the cost and value to homeowners of solarizing one roof, installing a battery in one garage, or doing it collectively? And so we built this modeling platform to look at the results first across California, but then much more. I'm not going to go into this slide at lunch. That's just ugly, but that's the mathematics of the model. But these are the places right now where we have teams that run decarbonization scenarios to both meet local goals and to meet national and regional targets. And of course, one of the interesting things you heard in the beginning, in the first panel, was what's the cost and what's the value to California in regionalization, not just in procuring least cost renewables, but in terms of jobs and leakage and a whole variety of features. And so we and other groups like mine who build and share these models, right, the business plan for an academic, totally opposite many view, is to do things and give it away for free, right? So somehow it's a very odd, non-productive business model, but we try to share as quickly as possible the results of these scenarios. And so without going in detail on each one, what I've just put up here are the different mixes of power from 2020 to 2050 for a whole set of scenarios, all of which meet that 2-degree target. Now, if I throw out the third one from the right, where we're not energy efficient, why would in California, after that beautiful curve, we do that one? All of the rest of these scenarios, some that are very heavy on nuclear, some that worry about the leakage of methane from our gas systems, some that minimize the use of hydropower because we're worried about preserving water and nature. All of these are different scenarios that get there, which is not very helpful. What it says is there's a lot of ways if we had a command and control energy system, which of course, thankfully, we do only in part. We have a system that strongly nudges us, but it's the innovations to figure out which ones are going to make most sense, not only at the large scale, but in bringing power affordably and reliably, not just, as we heard before, in people in the western coastal parts of districts, but in the eastern parts. And so I'm going to just pull out one scenario, the one that I've done the most work on myself. That is the one that we've seen with solar going from the most expensive to the least cost, or one of the least cost technologies, but also where batteries and energy storage follow suit. 20 years ago, almost no one thought that was a possible pathway for solar, and basically nobody thought it was a possible scenario for storage. And now here we are. The costs of solar have done this remarkable plummet so that, I'll skip that, so that now we can think about not only deploying solar at scales from our individual devices on our phones to home rooftops to neighborhoods, but also have things like this, flow batteries, and I suspect the installer, I think I might see the installer in the back, a flow battery powered by solar as part of California's storage mandate. This is something where no amount of forecasting would have let us think these are types of technologies we can install at utility scale. Now, this is an interplay between the regulations in the state's storage mandate of 1.2 gigawatts, but also rapid learning. And it's that rapid learning I want to spend a few minutes on because it's exactly where we see not only the challenges for CCAs to be literally on the bleeding edge of some of these issues of technology and management, but where the learning is really exciting. So let me just highlight those kind of briefly to tie them together. So that remarkable decline in the cost of solar is captured in almost everyone's financial models by a learning curve, where the price of solar has steadily fallen decade after decade, and this is a peculiar sort of plot for those of you who don't think in these terms every day. Time is not the vertical or horizontal axis. Time is just a date stamp along a curve where it's the cost in log units versus total deployment of solar. And we're now in a place compared to the 70s where the price of solar has fallen astronomically. It literally started out being installed on space stations to a point today where solar in the right area, as you all know, is a lowest, in some cases, a least cost technology resource. 10 years ago, that was even in question whether this will continue. And today we have this amazing progression. It just says that you deploy more and you get this remarkable fall in costs. But this has left out something which all of you who are looking at how to make CCAs work have been dealing in the weeds with, and it's been part of this story that's been lost. So what I've described so far is simply cost falls as a function of the volume of technology deployed. Well, that's not the whole story. That's the interestingly detailed story where each individual solar technology is aligned. This just shows the maximum efficiency of a whole bunch of solar technologies, from crystalline to thin film to the emerging ones that are not even being deployed commercially yet. Quantum dots, some of the perovskite ones that are just on the edge, all of these new technologies. That diversity is actually why solar could do it. When you run into a roadblock on one technology, expensive large crystalline cells, we had other people pushing on thin film. I literally had a battle with my graduate advisor who'd won a Nobel Prize, who said, thin film will never be a player. You can never outpace the efficiency of crystalline. Well, wrong, right? Nobel Prize not retracted, but not correct, right? This diversity led to this really healthy competition within the sector, and different ones of you are champions of and deploying different technologies. Just want to remember that, because that same story we are now seeing in other areas. I'm going to skip the details of the math, but here's the same picture. Now I have put time along the horizontal axis, and solar is that yellow line with the big drop when we got a large increase in crystalline plants in around 2005 in China. But if you look in detail, these curves now for solar and wind and storage are all showing the same behavior. In fact, energy storage is now innovating and improving at a rate equal to or greater than wind or solar ever did. You go back 15 years in the literature and nobody was saying that. And that was a result that didn't come out of economic analysis, didn't come out of material science analysis. It came out of trial and error deployment and figuring out which of these technologies worked in different settings. Now, that is a risky and scary message for first-time deployers of technologies, but the mixture of innovative California public sector and universities, and most critically private sector, worrying about everything from least cost power to the environmental justice implications of the materials to how do we install solar so that renters can also take part in that. All of those features are now baked into SB 32. So our next 12 years of innovation from today until 2030, when we have to make good on that 50% renewable energy target, are critically going to be dependent on the diversity of lessons that's coming out of the CCA movement. And I highlight this because it exactly illustrates that story. We started working with Commissioner Diane Gernich and others on a standard to have homes in California all having solar on the roof. There's a backlash in the literature today, people saying, well, you sprung this on us. Well, sprung it on you if you count, we wrote this first in 2008. And now we have people saying, oh, it's not fair, you didn't tell me, right? This is now law in California to have solar on every rooftop that we build after 2020. Didn't seem possible in 2008 based on cost, but based on looking at these technology progression curves and figuring there will be some interesting pushback. I would predict there will be some areas where renter-dominated, not easy to work out the solar garden and other laws to put solar on the rooftop, where we will start to see third-party hosting not only of solar, but also of storage, so that we can make this available across income levels. And that's really one of the challenges you heard in the morning panel. How to diversify the benefits of this transition because of all the reasons that you all know when you heard when we started the day. Making the reliability and the cost security of this available to all Californians, partnering out of state so these messages can move more quickly. And in fact, as we look at how this is spread, now we have solar going in around the world. It was 2.99 cents 2 years ago. Just recently, 1.7 cents for solar was at accepted bid. We now have people thinking about baseload solar, solar at 1 cent a kilowatt hour, adding the storage in so that you can now think about making this really ubiquitous in developments that we previously didn't think were possible part of the story. And that, of course, leads me to my final comments, and that is we have a whole bunch of challenges in terms of thinking about California's mix that, in fact, the CCA movement and the ability to innovate quickly really changes. And so, of course, everyone in the room has had their own arguments, and I certainly won't get universal agreement on the duck curve. And I don't want to make it sound like I think the duck curve is Y2K, but I almost think it's Y2K. And by that I mean we should absolutely worry about it and think through the implications. But this solar plus storage revolution allows one way to deal with a problem that consumes not only analysis in California, but many groups outside California, states, provinces, countries that look at us and say, well, they're going to have this huge problem of this tremendous ramp rate. Well, in fact, as we think about that ramp rate, for us, what it really is most likely to mean is that our overgeneration during the day is going to need markets. And whether that's merchant storage plants, literally powering up batteries. I recently received a proposal for a company that wants to do pumped hydro with no hydro, so they want to run rocks up a railroad and bring the rocks back down just like pumped hydro. It makes perfect sense. All it is mass times G times H. But when you look through where we are now, it's remarkable. Now we're starting to see the first induction charging, not just for large buses, but induction charging for vehicles, so that a lot of the logistics of you have three recharging places at your business. How do you move the vehicles around? How do you unplug them? Much easier. The idea of not only doing stationary storage, but induction recharging as you drive down the road is now being tried. So you recharge your battery as you go, whether you're a taxi or a long-haul trucker or just a regular citizen, and it comes off of your Easy Pass. And so you're paying as you drive to recharge your vehicle. Again, none of these were in the planning horizon 15 years ago. The same story I highlighted for solar, we also see in the data for storage. And so this is the learning curves for different storage technologies. Lithium-ion, lead-acid, a whole variety of technologies. We don't have enough data yet for flow batteries, but the exact same diversity that we saw that made solar something that you can champion in hot areas and cool areas. We now see the same thing here for storage. And if you have really sharp eyes, you'll notice that two little curves don't follow the seeming pattern of this roughly 20% decline in cost every time you double the number of units sold. And those are pumped hydro, and you'll notice down here we also have lead-acid batteries in cars. And neither of those should surprise you, because pumped hydro is not about manufacturing and lean manufacturing and just-in-time delivery. It's about finding the right geography. So it's no surprise we don't see learning for that one. And lead-acid batteries have been around, of course, since 1903 in large production for cars. So again, it's not a surprise that today in 2018 we're not seeing a lot of progress there. But all of the rest of these technologies are ones that we're seeing really interesting innovation. I just got a patent proposal to review, I can't say what company comes from, Volvo, but it is for a gel battery that will also serve as crash protection on the sides of cars, because when it gets impacted, it hardens. And so you get all of these kinds of interesting, clever applications for things that we weren't even thinking about, and that's really the beauty of the diversity of the process. In fact, that cost declines we're seeing on the solar and on the storage side now allows people to start setting up charging stations where you can charge day or night your electric vehicle, because it's got enough storage capacity at low enough cost built in. That is a service that CCAs can provide not only to their members, but they can also now provide as a revenue-generating service for people who drive up. And so there's all kinds of interesting opportunities to take advantage of this really rapid flow of innovation right at the time that we're not only looking for ways to install more distributed solar, but also to diversify the product stream so communities can think about these mixtures of different technologies as revenue opportunities. And again, I'll put this one up just because it's going to rankle someone the wrong way, and it's always worthwhile. These are a bunch of learning curves, and the one that stands out is nuclear. And it's not necessarily a function of the technology. It's that everything else is a small, scalable, ramp-up technology. It takes building a lot of reactors, even if they're done ideally, people's opinions may vary on that one, to get that same level of learning. Now, this is data from the United States, and we haven't built a functioning nuclear reactor since 1996. So if you're a super proponent of nuclear, you would say that might be true in the past, not true in the future. That's a perfectly valid argument against. But none of you, at least I hope not yet, are thinking about CCAs with small modular nukes involved. Maybe there's now and then there's one in the audience, but all the rest of the technologies that are likely to be part of your technology set are ones that we see this very steady, very intriguing learning going on over decades. So I've highlighted that. The last thing I want to bring up is how quickly this is changing our conception of how neighborhoods can think about energy. I mentioned the switch model and the planning we do to think about these aggressive distributed renewable and storage scenarios. Well, we work with a very large team of colleagues in China that every time I go over, all set to announce some exciting new thing in California, I always walk away defeated. I just went over and said, we've got this 1 million solar roof mandate. People thought we were really skeptical 6 years ago. Now we're going to get there or get close. Now we have a 1 million electric vehicle mandate, and they just told me when I was last time, oh, you know, our mandate for 2020 is 5 million electric vehicles. And now we're thinking about how quickly can we turn the president's intention to phase out internal combustion vehicles on the road and production. And China is, of course, the world's largest vehicle manufacturer. How quickly can we turn that into a number? Meaning, in what year will China turn off the manufacturing of internal combustion vehicles, and how quickly will they turn off the permits to allow them on the roads? That is a transformative statement about the materials needs for renewables and about the market opportunities. And that's going to drive even more creative abilities to think about how communities, large and small, can take advantage of this overall process. And of course, you know, every day we get a new picture of, will the Tesla long-range truck, will another vehicle be available to think about not only taking away the carbon emissions of our personal vehicles, but long-haul freight. We've now seen proposals for electric airplanes, things that we just thought were science fiction literally a decade ago. So I want to conclude with this one last piece of the story, and it's in some ways the hardest one to quantify, but it's the one that everyone in the room who toiled for SB 32 deserves a huge hand for. We not only have this wonderfully challenging, and I think optimistic for most of us, goal of 50% clean energy by 2030, and as you heard before, that doesn't include nuclear, doesn't include large hydro, but also a carve-out, a very significant carve-out for environmental justice. And so one of the features is, how do we really take these lessons and make them available across income levels and communities? That's often the hardest part of the story. But aggregating larger areas that are more diverse is one of the ways that CCAs can be on the leading edge of making these benefits available to all Californians and to the states and countries that will listen, but also the behavioral part of the story. So one of the things that humans are not good at is calculating exact quantities, but we're really good at knowing, are we 1% better or worse than our neighbor? In fact, we're exceptionally good at that. So tools like this that do carbon footprint or water footprint analysis of cities and communities allow us to start understanding, why is it better in one area? Is it because of forces that seem outside our control, power we buy from long distances? Is it local weather? Is it taking advantage of things? So in the Bay Area here is just one of these maps. That Cool Climate website is one where you can both see the pictures, but you can also download the app so you can do it on your phone. And I guarantee the first thing someone who does it, they'll look at yourself and you'll look at the neighbor that you either most like or most dislike to figure out how they're doing in the process. But these have been incredibly helpful in trying to figure out what are the comparative advantages at very small scales. This is down to the census block level.
In fact, a last piece of this is that a project that we are launching in Oakland, which is essentially a mini-grid, but it's a mini-grid not only for energy, but also for water and for waste, is an example exactly of a question that CCAs can answer that neither large-scale utilities nor homeowners can answer easily, and that is, what is the optimal scale to install distributed energy? Is it the rooftop scale, the home, the garage scale, because you control the assets in a simple way? Is it the large-scale utility? Or as more and more practical projects are starting to uncover in California, in Australia, in Europe, in Kenya, in Bangladesh, in South Africa, is that for many technologies, it's actually a larger intermediate scale. So here's a 40-home block off São Pablo Avenue in Oakland that are a test bed for solar on all the roofs, but pooling the storage in this one garage, the gray building off to the right-hand side, where all the power will be pooled, sent back to the homes, sent to power the electric vehicles, and then the excess sent off. And that's, of course, the heart of the model that many of you are championing. And again, these lessons, in this case it's with support of the California Energy Commission, are examples of what we're seeing community by community. So in my own case, we are part of the East Bay Community Energy CCA, and we are seeing a lot of those issues and challenges being played out. And so again, I hope this highlights both how these pieces fit together, but how critical it is to get feedback on what works and what doesn't work, not just on the technology to your suppliers, but to the regulators, to the end users, so that we can get these messages out as quickly as possible. And that's really been the challenge in thinking through this process. And of course, all of you who I hope will be at the Governor's Climate Conference in September, are going to have the opportunity to work directly around the experiences at the local and regional level and how they partner around the planet. Because as of this point, over 300 municipalities around the planet have signed on to the Under 2 MOU that Governor Brown, the California and Schleswig-Holstein and Germany are the co-chairs. And this map of places that have signed on to that pathway are going to be the next markets for many of the technologies and the products that you've done here. So I suspect I haven't said much that many of you don't know. I hope I've packaged it together, and I hope I've also given you a bit more motivation for how and how quickly we need to get the lessons, both good and bad, on the technology, on the regulation, on the private sector interface, and in particular on the social justice interface to make this process move even more rapidly. So thank you very much for letting me speak. I appreciate it.